forget. This will help you in a lot of questions. Strong attenuator. Start with the S. Example is a tone. Start with also an S. Behind them you're going to have a shadow. Start also with an S. Behind means underneath, distal or beyond. But again, let us say it again, guys. If you have a strong attenuator like a stone, you're going to have a shadow underneath. Make sense?
Yeah.
When you have a weak attenuator, here I don't have the letter S, I don't have any letter, I just go with what is a weak attenuator such as blood or cyst. If you have a weak attenuator as blood or cyst, distal to it, you have a bright image called enhancement. Again, if you have a weak attenuator such as a blood or cyst, behind to it you will have enhancement. Again, if you have a weak attenuator such as a blood vessel or a cyst, behind it you have a brighter area called
Enhancement.
Make sense? By the way, this guys is found in chapter 6, but the questions on chapter in your packets are asking about it because I'm giving you attenuation. So this is applicable now. To answer the packet, you have to know that. This is why I'm giving it to you. So what is the reason for edge shadow? Attenuation or refraction? Edge shadow. Edge shadow.
It's a refraction.
Edge shadow is refraction. Okay. What about shadow beyond the stone? Attenuation. Excessive attenuation. Is a stone a strong attenuator or a weak attenuator? Stone.
Strong.
Strong attenuator. Okay, and beyond the stone there will be a shadow or enhancement?
Shadow.
What about the blood vessel? Beyond it there is enhancement or shadow?
Enhancement.
What about the cyst?
Enhancement.
Enhancement. What is the enhancement? A brighter image or a darker image?
Brighter.
Beyond the weak attenuator or a strong attenuator? This brighter image is beyond a weak attenuator or a strong attenuator?
That's
Weak.
Weak attenuator. Because it is beyond a blood vessel, which is a weak attenuator. So the enhancement is beyond a weak attenuator. But a shadow is beyond strong. So shadow, we start with letter S, strong attenuator. It's kind of confusing, guys. That's why I'm giving it to you many times until you get it. Okay. Okay, let us go to another topic now. Guys, would you mind, guys, like studying this stuff today, like in the lab part, after you finish with Mr. Lee and you finish scanning, do all of the lab, study this. Okay, and I am ready to answer your questions, but don't leave it by time. If you forgot that, difficult to retrieve it. Just do it on spot today. I am now talking about attenuation again. Do you remember the unit of attenuation, guys, I gave yesterday? What is the unit of attenuation? Look up the notes, I don't mind. Excellent. I measure the attenuation in this, which is the unit of log of ratio of intensity or power. This is, guys, the unit of attenuation is decibel, and decibel is the unit for attenuation, which is log of the ratio of intensity or power. Make sense? I told you guys that if I start with a big number like that, and I end with a small number like that, I count how many zeros I lost. I lost actually these 4 zeros. Each zero I lost is minus 10 decibels, so the total is minus 40 decibels. Okay, I got them. But I want to count it in a different way. Like, can I calculate the attenuation? The answer is yes. There is, guys, a formula. I would like you to know it. This formula says that attenuation, which is measured in decibel, is equal to the frequency times the pass length divided by and it makes sense, by the way, guys. You remember, guys, as I told you before, as the frequency increase, attenuation increase. As the frequency increase, the attenuation increase. I also told you that as sound travels, this is the pass length. It gets weaker, which means that attenuation also increases. So guys, let us repeat that again. As frequency increase, attenuation
Increase.
increase. When you have a higher frequency, you are easier to get weaker. This is why in high frequency we can go deep. There is no penetration because I am easily attenuated. So with high frequency, attenuation is more. This is asked about. When you increase the frequency, you increase the attenuation. When the sound travels for a long distance, the longer it travels, the more it will be weaker. So guys, I want to know the amount of weakening. Okay, know the frequency multiplied by the pass length divided by 2. We get the amount of attenuation. Memorize it. The equation to memorize. Attenuation times frequency divided by attenuation times frequency divided by 2. Whatever comes out, guys, whatever number comes out, it will be measured in dB. dB is the I have a frequency of 10 megahertz, and I traveled 5 centimeters. What will be the attenuation?
Repeat that?
I am using a transducer with a frequency of 10 megahertz. So the frequency is 10 megahertz. And the travel is 5 centimeters. Like the sound travels in the body for 5 centimeters. What will be the amount of attenuation?
25.
25 decibel. Here we go. What did he do? Orlando just get the frequency amount, put it here, and he multiplied by the pass length and put it here, and he divided by 2. Why I give you that equation? I have a purpose. I want to tell you that the frequency has to be measured in megahertz, and the pass length has to be measured in centimeters to get that value in. And the value here, as you told me, become 25. 5 times 10 is 50, divided by 2 is 20. Okay, this part is just an equation, but we have to know. This equation is a simple equation, so they're likely to ask. When a complication, guys, is complicated, they don't ask about calculations. But because this equation is simple, they ask about calculation. In this one. It's just simple equation. Let me talk about another thing, which is something called attenuation coefficient. that? Is it different from the regular attenuation? Yes, it is different. What does it mean? Attenuation coefficient is amount of attenuation when the sound travels only 1 centimeter. So it is not the total amount of attenuation, no. Amount of attenuation per centimeter. Per centimeter. You know, it's like what? It's like I am telling you guys that my car consumes 25 gallons per 25. It can drive up to 25 miles per gallon. This is like the attenuation coefficient. Like, as far as I am using 1 gallon, I will drive 25 miles. It is not changeable. It is not changeable. Okay, how many miles did you really travel today? Oh, today I traveled 100 miles. So how many gallons did I use?
4.
4 gallons. Because for 1 gallon, I am using it for 25 miles. So for 100 miles, I'm going to use 4 gallons. This is the attenuation coefficient. Like this is something similar to attenuation coefficient. But this one, guys, is similar to the attenuation. Like, I know that when I'm reading that transducer, each centimeter I travel, I will be attenuated by 10 decibels. In each centimeter travel, just 1 centimeter travel, I know that I will be attenuated by 10 decibels. Okay, how many centimeters does sound travel in your body? 10 centimeters. Oh, in that case, you are attenuated by 100 decibels. It makes sense, guys? Because each centimeter you travel, you are attenuated by 10 decibels. Each centimeter you travel, you are attenuated by 10 decibels. This is called attenuation coefficient. The amount of attenuation when the sound travels only 1 centimeter. It is like as if I'm saying to you that my car is consuming 25 miles per gallon. It's a given. When I bought that car, it is a given that while I'm taking the keys of that car, I know that it is driving 25 miles per gallon. The same thing. When I give you the transducer in your hand, I'm telling you it is a given that this transducer, the attenuation coefficient is 5, which means that each centimeter travel of the sound from this transducer, it will be attenuated by 5 decibels. A given. Okay? Let me talk about it a little bit. When I say to you guys attenuation coefficient of that transducer is 5, it means that each centimeter the sound will be
5.
weakened by 5 decibels. But what is the frequency of that transducer? It is 10. The frequency is double the amount of attenuation in 1 centimeter. So I just will say that it is equal to frequency divided by
2.
So I know, it's a given. As I told you, like as if they're giving me the key of the car, they're giving me the gallon per mile, the same thing. When I give you the transducer, what is the frequency of that transducer? 10, the attenuation coefficient is 5. It is 7, the attenuation coefficient is 3.5. It is 5, the attenuation coefficient is 2.5. It is the frequency divided by 2. It is like something that is given. Who will determine if the frequency, whatever the frequency that the transducer is having, divided by 2, you're going to get the attenuation coefficient. The higher the frequency, the more the attenuation coefficient. The lower the frequency, the lower the attenuation coefficient. I give you a transducer with 20, which will never happen. What will be the attenuation coefficient? 10. Frequency divided by 2. So guys, if you want to calculate the attenuation coefficient, get the frequency divided by 2. Okay, what will be the unit of attenuation coefficient? It's decibel. But I will put it per
7.
and it makes sense because I'm measuring the attenuation in each centimeter travel. It is just equal to the frequency divided by 2. What about the whole attenuation? No, this is a different story. If I want to know how many gallons you used today, you have to tell me how many miles you drove. You have to give me an idea about the miles you drove. The same thing is here. If I want to know the total amount of attenuation, you have to tell me how many centimeters did I travel in the body. So it is the frequency divided by 2, yes. But I have to multiply it by the centimeters I travel. Is it making sense? I am leaving attenuation now. This is the whole thing about attenuation.
Just this part over here.
I will not clear anything.
Okay, on this
Yes.
one you're saying that's divided, it's attenuation frequency multiplied by path length divided by 2.
Yes.
On this part, you're saying just
Frequency divided by
6.
That's it.
Okay.
And this one is measured in decibel. That one is measured in decibel per centimeter.
Okay.
This is the second thing. Guys, if you don't get it, I can repeat again. Attenuation, guys. How much I get weaker? How much I get weaker per step? This is called attenuation coefficient. How much I get weaker as far as I travel? This is the attenuation. So per step, this is called attenuation coefficient. Per step is called attenuation coefficient. In the whole travel, this is called attenuation. Let us say that I moved from here to Rolando. Let us count the step. And each time I make a step, I am weakened by 5. So 1, 2, 3, 4, 5. I did 5 steps till Rolando. And in each step I am weakened by 5. So how much I totally get weakened? 25. Because each step is 5 and I make 5 steps. So the total amount of weakening is 25. The weakening that happens in each step is called attenuation, which is 5. But the total amount of weakening that happens since I started till I end, which is 25, is called the whole travel area. But in order to know the total attenuation, I have to know how many steps did I do. The same thing here. I have to know that how much centimeters did the sound travel.
50? No, 25.
Here,
5
yes,
times
25.
10.
Make sense, guys? What is the attenuation coefficient of a transducer of 10?
5.
You have all to answer that, guys.
5.
This is, yeah, thanks. So, 5 what? Can you give me the unit?
Decibel.
Decibel per
Centimeter.
centimeter. The unit here will be decibel per centimeter. The unit is decibel per centimeter. The unit in attenuation is decibel only. There is no per or whatever. The total amount of weakening I got, look at how I worded, is 25 decibel. But when I say per step, I say the total amount I get weakened per step is 5. So I say 5 per step. Decibel per centimeter. Like I get weakened by 5 per step. I get weakened by 5 per centimeter. And I'm comparing the example I give. But the total amount I get weakened from here to there is 25.
25.
Decibel. I don't say per step. But in each step I say per step. Here that's the same thing. The attenuation coefficient is the amount done per centimeter. So I have to put per centimeter. Guys, this is also kind of important. Like you can have a couple of questions there. So calculation is a possibility here. That's easy because it is frequency divided by 2. Nothing. I'm talking about attenuation coefficient. Frequency divided by 2. What about the attenuation itself? Frequency divided by 2 times the path length.